Solving for a specified variable. So basically, we're going to be using the same solving techniques that we've done before, but now our equations are going to be looking a little bit different. Instead of just one variable, you're going to have multiple variables, and they're going to tell you which one to get by itself. So we might have something like y equals mx plus b, and they want you to solve for x. Okay, I moved that up to the top corner to give us some room. Let's say we had this separate equation over here. Let's say we had 7 equals 2x plus 1. Okay, now this may look a little scary because we've got a y, we've got an m, we've got an x, and a b. This one we've only got an x, but it's really going to be using the same solving techniques that we've done before. So looking at this right equation here, if I wanted to get x by itself, first thing I'm going to have to do is subtract 1. So I'd come over here and I'd subtract 1 from both sides. That would give me 6 equals 2x. Likewise, just because I have a b instead of a 1 here, I'm going to be using my same technique. So here, I'm going to subtract b from both sides. Now, because y and b are not like terms, I can't put those together. So now, when I do rewrite, I'm going to have y minus b separate is equal to mx. From there, looking at our equation on the right, we can divide by 2, giving us x equals 3. Same thing we're going to do over here. We want to get x by itself. We have this m multiplying, so we're going to divide both sides by n. Now we have to do this whole side by m. So we just put our fraction bar underneath everything. And solving for that, we'll get x equals y minus b over m. And there's our answer. Alright, let's try another example. Say we have km plus 5x equals 6y, and we want to solve for m. Okay, I look over here, I have my m on my left side multiplied by k added to 5x equals 6y. Alright, so I'm obviously going to start with subtracting away this 5x to get this km by itself. So if I minus 5x from both sides, we're going to get k times m equals 6y minus 5x. Remember, we can't put those together because they're not like terms. And now my last step, I have k times m, so opposite of that would be to divide by k. I want to divide this whole side by k. Those are going to cancel. We're going to get m equals 6y minus 5x all over k. Let's say we had c equals 3/4 y plus b, and we want to solve for y. So again, I have 3/4 times y. I have b added here, so we want to start with subtracting away this b. It's going to give me c minus b equals 3/4 y. And now this 3/4 y, we have 3/4 times y. To clear that 3/4, we can multiply by the reciprocal, which is 4/3. Now when I multiply this side by 4/3, I have to do this whole side all together. I can't just put it in front of the c. I have to multiply the whole side. So I gave myself these parentheses, and I'm going to say times 4/3 to this side. This is going to give me 4/3 c minus b, and that's going to be equal to, this 4's are going to cancel, these 3's are going to cancel, and that's going to be what my y equals. Okay, let's do another example. Say we had 3ax minus n all over 5, and that's equal to -4, and we want to solve for x. So looking over here on the left, I have my x here times by 3a. It's also has subtracted to an n, and it's all on top of 5. So this is a little messy, but to help ourselves out, let's always get rid of what's on the bottom when we have big fractions like these. So if we multiply 5 to both sides here, those are going to cancel. We'll get 3ax minus n. That's going to be equal to -20. Next, this kind of looks like one we've already done. we've got this 3a times x minus n, so let's go ahead and add this n over. Add this n, we'll get 3ax equals negative 20 plus n, because those ends canceled each other. Now finally, we want to get this x by itself. We have 3a times that, so we can divide this side by 3a, divide this whole side by 3a. Those will cancel, and we're going to get x equals negative 20 plus n all over 3a. And boom. Alright, let's do another one. Let's say we had 5g plus h equals g, and we want to solve for g. Okay, this one's a little different because I've got a g here on my left side. I've also got a g here on my right side. So our first goal is, let's put our g's together. So I'm going to go ahead and say, since I see this g is smaller, I'm going to subtract g over here. I'm going to subtract g over here. What's 5g minus 1g? 5g minus g is going to give us 4g. We still have plus h. Now g minus g, those are going to cancel, but g minus g is 0. So we have all this equal to 0. From here, it's really similar to ones we've done. We can subtract h over. We'll get 4g equals negative h divided by 4. And we're going to get g equals negative h all over 4. Alright, let's do one more example. Let's say we had 3y plus z equals a times m minus 4 times y, and they want us to solve for y. Again, here I notice I've got y on each side of the equation, so I need to put those together. I'm going to go ahead and add this 4y over to the left. That's going to give me 3y plus 4y is 7y, and I still have my plus z equals a times m. Next, I want to keep getting this y by itself, so let's get rid of the z. Minus that from both sides, that's going to give me 7y equals a times m minus z. Finally, I have 7 times y left, so I'm going to divide by 7, divide this whole side by 7. I'm going to put my answer up here. It's going to give me y equals am minus z all over 7.